Hola Calc. So today we're going to do some more with integration, and we're going to do integration by parts. So in order to do this, I want you to recall the product rule. So the derivative of u times v with respect to x is, of course, front d back, or in this case that's dv dx, plus back d front, which is du dx. Okay, so now what I want to do is I want to integrate. And we'll say now integrate with respect to x. So that means I want to take u times v, okay, because the integral of du times v dx is u times v, and that would be the integral of u dv plus the integral of v du. In other words, if I were to solve for the integral of u dv, that would be uv minus the integral of v du. And this is our formula right here for integration by parts. So that's the formula that we're going to be using, and let's do a handful of examples. So, number one, let's do the integral of x cosine x dx, of course. The idea is you want to pick a dv so that when you take the integral to find v, it's easy to find. You also want to pick a u that's simple, so its derivative is simple. So in this case, I'm going to let u equal, we want to pick the simpler function so that the derivative would be very easy. So I'll let u equal x, and I have no idea how I accidentally drew that line right there. Let's fix that. Okie dokie. So if u equals x, then what's the derivative of x? Well, that would just be 1 is what you're saying, so I'm just going to write 1 dx. And then if u is x, that means dv is going to be cosine x dx. And so now what is the antiderivative of cosine? And you're all shouting and telling me sine x. So the idea you want to think about is if both functions are integrable, okay, meaning you can take the derivative of both functions easily, you want to pick the simpler function for u. In this case, that would be the x. So when I take it following the formula, that is uv minus the integral of v du. So you can see what we've done is we have x sine x, which is totally fine, dandy, leave it alone, but we have to take the integral of sine x again. So I'm going to carry down this x sine x minus, and what's the integral of sine x? Oh, that's negative cosine x, or turn that into a plus cosine x. And we're done, but remember this is an indefinite integral, so we have to remember to put our plus c. And there we go. There's example 1. Okay, let's move on and do example 2. All right, I have the integral of x squared e to the x dx. Okay, so again, we want to pick a u, and we need to pick a dv. You want to pick a u so the derivative is easy, and that means I'm just going to go ahead and pick x squared. Yes, I understand. E to the x is a very easy derivative to take also, but it's also a very easy antiderivative to take in this case. That would make du 2x dx, and v, again, the lovely e to the x. So, setting it up, we have u v minus the integral of v du, and then you look here and you're like, what's happening there? It's not quite solved for. Looks like we have to go again. So we're going to go again, and you're going to have to pick another u. In that case, I'll just go with 2x, another dv. I'll stick with the same e to the x dx. So then du is just 2 dx, and v is still e to the x. And we go again. So that's x squared e to the x minus, okay, big ol' bracket here as we go again, u v minus the integral of v du. I'm just going to slap that 2 in front, close my big old bracket there, and that leaves us with x squared e to the x minus 2x e to the x minus, what is the antiderivative of 2e to the x? Okay, well that is 2e to the x. However, don't forget that we're distributing a negative, so this is going to become a positive, doing that all in one step. If you need to, write out 2 separate lines. I'm running out of space, and I'm pretty sure you can handle me distributing a negative and integrating all in one line. Slap that plus our constant on the end, call it a day. All right. If you have any questions there, feel free to jot them down and ask them in class. Let's go again. Number trace. All right. Changing up a little bit and saying, oh, solve the differential equation dy dx. When we have equal to x ln x, okay, given, of course, we're going to have an initial condition, y is going to equal -1 when x equals +1. All right, so basically, what does that mean? Well, we are solving for when dy equals x ln x dx, or of course, when we integrate both sides, y is going to equal the integral of x ln x. Okay, now, in this case, you're thinking, I need to pick a u, I need to pick a dv. And it never fails. Everyone thinks, whoa, what do you want to pick for u? I know what you're all thinking. You're like, oh, x. And then put ln x over here for dv. Okay, totally go with it for a second. What is du? Oh, that's dx, Ms. Gutierrez, or just 1. Awesome job, guys. What's the antiderivative of ln x? And here's where everyone stops and you hear crickets. So we go back and we change this up, and this is what you do. If you pick a dv or u that's not easy to find, you go back and you change it. So use ln x, and dv is x. So what's the derivative of ln x? That's 1 over x dx. Running out of room. And the antiderivative of x is x squared over 2, or 1/2 x squared, whatever way you want to write it. So, solving, we have uv. Okay, I'm going to put v in front, so that way we know we're just taking the natural log of x, which is fine, minus the integral of v. Can I take the 1/2 in front? Am I allowed to do that? You betcha. Okay, du. And look what happens here. This changes, so I now just have 1/2 x squared ln x minus 1/2. What is x squared times 1 over x? That's just x. Okay, so now take the antiderivative, and we're right here. So antiderivative of x, of course, is 1/2 x squared times the 1/2 in front. We're going to have minus 1/4 x squared plus our constant. Okay, remember that equals y. Now we have to plug in our initial condition they gave us. So when x is 1 and y is -1. So plugging back in, that is 1/2 1 squared ln 1 minus 1/4 1 squared plus our constant has to equal -1. Everything over here, because the natural log of 1 is 0, so everything over there is 0, minus 1/4 plus c equals -1. Or solving for c, we get -3/4. So our final answer is 1/2 x squared ln x minus 1/4 x squared minus 3/4. Awesome job. Here we go. Let's go again. Number 4. Okay, sometimes we're actually going to use integration by parts to solve for the antiderivative of one function. Okay, remember before we had issues and we're like, ooh, what's the antiderivative of ln x? Well, let's use integration by parts to actually solve for it. So, u equals ln x. And we'll just let dv be dx. That means du, just like in the problem before this, 1 over x dx, and v is just x. Setting it up, uv, in this case I want to write vu, it's multiplication, so it's totally allowed, minus the integral of v du, which becomes x ln x minus the integral of dx, or we have x ln x minus x plus c. Now, sure, you're probably thinking, well, can I just memorize that and that can be a rule for the antiderivative of natural log of x? Sure, if you want to, or you can always just use integration by parts and solve for it. It makes it nice and easy. But if you want to add another rule to remember, that's totally fine and you can go for it. All right, let's do what you do. Number 5. Can I please? Okay, there we go. Wow, I don't know if you guys are seeing that, but I'm accidentally hitting the page back button every time I try to circle my number 5. And if you are, I'm sorry, but here we go. All right, x squared sine 3x dx. Okay, here's what you should do. Pause the video, try this problem, then hit play, and let's go over it together. So, hopefully you picked u as x squared and dv as sine 3x. That would make du 2x and v would be -1/3 cosine 3x. Okay, so setting up uv x squared. I should have put the -1/3 in front, but I didn't. That's okay. I'll fix that later. Cosine 3x minus the integral of v du. Okay, so I'm going to go ahead and take that 2/3 or the -2/3, put it in front, so we're going to be adding it together. And now I have x cosine 3x dx. And you're probably thinking, what? We have to go again. Why would Miss Gutierrez make us do that? And you're saying, that's okay. Okay, so let's write it out again. So negative 1/3 x squared cosine 3x plus 2/3 big ol' bracket. Okay, so now we're going to go again. What are you picking as your u? Okay, I'm going to erase all this. Ran out of room and I did not write down my u and my dv. And some of you might be thinking, do you always have to write down your u and your dv? And no, if it's easy enough that you're able to, you don't have to. It's good habit to always write it down though, especially because when you take the quiz, if you make a mistake, partial credit. So then du is just dx, and then our v here is positive 1/3 sine 3x. Okay, now let's write it down. Negative 1/3 x squared cosine 3x plus 2/3 big ol' bracket uv, or 1/3 x sine 3x minus the integral of v, taking that 1/3 in front, so minus integral of sine 3x dx, close your big old bracket, or negative 1/3 x squared cosine 3x plus 2/9 x sine 3x minus 2/9 times the integral, and that's negative 1/3 cosine 3x plus our constant. And again, you can totally leave it like that. Remember, you're not required to simplify, but if you want to, cosine 3x plus 2/9 x sine 3x plus 2/27 cosine 3x plus our constant. There is our final answer. So, although it's not horrible to integrate twice, okay, or to do integration by parts twice, wouldn't it be nice if there was an easier way? And there is, and that's going to take you to video 2. It's called tabular the tabular method for integration by parts. And check out video 2 for that shortcut. And I will talk to you guys later on. Have a great day.